Ciliary Johnson. I am a professor at Texas A&M University, and today we're going to talk about the eye. We'll talk about the outline of the presentation, the functions of the eye, layers of the wall, structural features and functions, the ciliary muscle, ciliary body, ciliary processes, secretory cells, trabecular meshwork, and the canal of Schlemm. We want to cover the things through which light passes, which is the cornea, the lens, and the transparent portion of the retina. And we're going to talk about things that influence the image, which is the iris, regulated amount of light coming through, the ciliary bodies, and the trabecular meshwork. And here we can see the eye. We see the major globe of the eye, the vitreous body inside there. And we can see a couple of three layers that we have there, composed of different layers. Cornea, lens. Between the eye and iris is the posterior chamber, anterior chambers is at the surface up through there. And it's aqueous humor that's in the anterior and posterior chamber, vitreous humor in there. Now, if you know the workings of a camera, then you already know the workings of the eye. The shutter would be the eyelid. The diaphragm would be the iris. The lens is the lens. The sclera is the white of the eye, or the structural part of the camera. The choroid is the blackened box on the inside of the camera. You've got black to prevent backscatter of light. And then the photosensitive film would be the retina. And in fact, there's three layers of the eye. There's a supporting layer, which is the sclera, the white of the eye, and the cornea, and that makes a complete globe. That then pressure is exerted to the eye to keep the globe open, kind of like a basketball is pumped up with pressure. But the secretion of the eye is about twice that of the eye for a day, for the total volume of the eye for a day, and so therefore you have to regulate the outflow, and we'll talk about how that occurs. The next layer is the vascular layer, and that is your choroid, as well as the ciliary processes and the iris itself. All of those are a vascular layer. We call that uvula. And then there is a retinal layer. It comes up from the optic nerve, and it comes around here all the way up to here, where it no longer is photosensitive, but it continues all through here, and is actually part of the iris itself. So the pigment and the dilator muscle are all part of the retina themselves. So we have the cornea, the iris, ciliary bodies, lens, vitreous body, as we saw a while ago. Now, the main part of the eye, of course, is the retina for photoreception. And here we see the rods and cones, pigmented epithelium, bipolar cells, and the ganglion cells, the different layers that make it. And so the light comes in through here and projects up through there, and finally it hits the photosensitive portion of photoreceptor cells, which are here. Here's our nuclei, here's some of their cytoplasm, but the photoreceptor portion of them is right down in there, and then you have the pigmented epithelium. Below that, you have the choroid, the rich vascular supply. So we'll learn all those words. So the conjunctiva is the stratified squamous epithelium that's on the inside of the eye, and also it covers the white part of the eye itself. Stratified squamous epithelium, non-keratinized because it's basically in a liquid state. And then the sclera is the white of the eye that we see here. So the conjunctiva is right over through there, and that's what we see in through there. So whenever the cornea was developing, here's the cornea here, the epithelium from the skin, the stratified squamous epithelium from the skin, came in through there and made the conjunctiva surrounding the inside of the eyelid, as well as covering the white of the eye as well. And so then we still have stratified squamous epithelium at the top of the cornea, as we'll see in a minute. So in terms of looking at a real eye, we have the sclera here, this heavy band of connective tissue, the retina in through here. Right between the retina and the sclera, you have the choroid layer, and it's right in through there, right above the sclera, all in through there, and that's a rich vascular supply that provides nutrients to the retina. Then we have the lens, and this is where the pupil would be, the opening there between the iris. Actually, iris goes all the way around and makes a circle, but we just see two projections of the iris: the posterior chamber, anterior chamber, lens, iris, ciliary bodies, sclera, as you can see, retina, the different portions. If you look at the back of a monkey's eye, we see the optic nerve coming in through there, bringing blood vessels in through a nourishment of the retina itself, and then the different layers of the retina, including the choroid. The dark part here is the choroid. Remember the blackened box. And also it has a rich vascular supply, some nerves out through there, but that's basically the structures that we will see. If we look at the cornea, we just stratified squamous epithelium at the surface, Bowman's membrane, a little membrane through there, and then you have the stroma cells, the keratocytes, or the fibroblastic-like cells that you see there, and they're sparse. The nuclei are far apart because there's a lot of fibers between them. And below that we have the descemetous membrane, which is the basement membrane of these transport endothelial cells. Usually they're cuboidal or somewhat squamous, mostly cuboidal, low cuboidal epithelial cells. So we have 5 basic layers from the inside, from the outside to the inside of the cornea. We can see those here. If you see the stratified squamous epithelium on the surface, Bowman's membrane here, and then you see the stroma, and the stroma has corneal fibroblasts. You can see the nuclei of these cells, you can see the cytoplasm of this cell, and there's a lot of fibers in between, and those fibers are arranged perpendicular to one another so that it selects out desirable light rays. So you have stroma from there to Bowman's descemetous membrane, which is a basement membrane of these transport endothelial cells that are on the surface, the anterior surface. The anterior chamber surface is really the posterior portion of the cornea that you can see there. Stratified squamous epithelium is what we see there. Stratified squamous epithelium continues with the conjunctiva and through the Bowman membrane, stroma, descemetous membrane, cornea, endothelium. This is endothelium, not epithelium, endothelium. As we can see there, here's the iris, anterior chamber, posterior chamber, and the aqueous humor is the liquid that's in both the posterior and anterior chamber. It's actually produced by these ciliary processes. The secretory portion goes around the iris and then is removed up in this region. As we'll see, here's a ciliary muscle in through there, which is located right in located all the way around, of course, but we just see it on either side, right where the iris comes into play, is attached. In the ciliary muscle, we can see it's a smooth muscle. We can see nerves. We can see blood vessels of the ciliary muscle, and the ciliary muscle is what contracts to change the shape of the lens. And also here we see the ciliary processes. These processes, you have secretory epithelium on the outside and pigment epithelium on the inside of both these images, and then there's a lens. Iris pupa is an opening in through there. This space here is artifact. This shouldn't be. You should have no space here. Ciliary muscle, and this is where the sclera comes in contact with the cornea. Cornea has no blood vessels in it because that would interfere with light coming through. And right where you start picking up these blood vessels here is the sclera-cornea junction, and that's known as a limbus. Important region in through there. And right below there is trabecular meshwork and the canal of Schlemm. And so here we can see the ciliary processes that are in the anterior and the posterior chamber, and they have secretory epithelium on the outside and pigmented below there, as you can see, and we'll understand that here a little bit later. But the pigmented epithelial cells become a dilated muscle under the iris, and the secretory cells become pigmented under the iris. So you have a double layer that comes in from the retina, and they continue to be double layers, but they have different roles when they hit the iris. Now, we mentioned that endothelial cells here as opposed to epithelial cells out on the outside. So these endothelial cells, which are really endothelial cells, and they're continuous with the endothelium of the trabecular meshwork. And trabecular meshwork actually comes all the way in through there. And then, so fluid comes through there, goes through the trabecular meshwork, goes through the connective tissue, and goes through the endothelial cells with the canal Schlemm to get out. And that is the outflow of the fluid. They're produced over ciliary processes. The secretory epithelium secretes it. Fluid migrates over through the pupil, and then ultimately is outflow. But the trabecular meshwork is really resistant to the outflow. If there was a direct connection with a canal Schlemm between the anterior chamber and canal Schlemm, there'd be no pressure. And so it maintains a little bit of pressure by uniform pressure by regulating the outflow, and it resists the outflow. So there will be some pressure built in the eye, but it doesn't prevent it. It just resists as a main function. But endothelial cells here are continuous with endothelial cells of the trabecular meshwork. Here again, we see the trabecular meshwork in through here, little openings of these endothelial cell lined spaces, and these spaces here are continuous. The lumen is continuous with the lumen of the anterior chambers, where you have the aqueous humor being absorbed in through here, and ultimately going back to the bloodstream via the canal of Schlemm with no lymphatic in the way. Here we see the ciliary muscle, the limbus region. We're right in this region, right in here. There's a lens, a cornea, as we can see. Here's a canal of Schlemm, trabecular meshwork, and another view. This is the iris, and the iris here we can see it has dilated muscle in through there, and it has pigmented cells. Blood vessels, remember the iris was part of the vascular area layer of the eye, and it has blood vessels inside there. Have to have continuous capillaries to prevent antigens from going in through there, because the aqueous, there's a blood aqueous barrier. So blood-borne components have a hard time getting through. We don't want them actually into the liquid of the eye. Ciliary processes, as I mentioned, you have secretory cells on the outside, and then they become pigmented on the iris. The pigmented layer of the ciliary processes become the dilated muscle, and so we have dilated muscle. Dilated muscle is myoepithelium. It's not smooth muscle, it's myoepithelium. We want to thank the various textbooks and original sources of materials for figures, images, and drawings that we have used in this presentation. We want to acknowledge the original source of those and thank them for their contribution. This is the end of this presentation on the eye, where we looked at the outline, function of the eye, layers of the wall, different components of the eye, including the trabecular meshwork and the canal of Schlemm.